So you just practice ad nauseum the law of sines. Lots of cross multiplying, lots of dividing, inverse to help find the pieces. So what is it useful for? So we're going to see how it's useful in some of those situations where we were doing word problems before, but those word problems, everything was perfectly a right triangle. And in real life, that's just not true. Okay, you put up, the stuff with a tree. A tree is really not usually a right triangle because something often happens to the tree as it grows that makes it not grow perfectly straight, or things just don't work out. Like the bearing questions always worked out to be perfectly 90 degrees. Well, that's not going to be the case. Okay, so let me show you how that's going to work out. So let's consider a tree. If you've ever been to the sequoias or the redwoods in California and looked at those gigantically monstrous trees that have been around for 1,000 years, okay, they're tippy. They don't grow straight. So let's imagine that you are an arborist working for the National Forest Service, and you need to measure the growth, the height of that tree, and how much it has grown. And so you place yourself at a position where you can measure the height of the tree. All right, and so using your surveying tools, you determine that the tree is leaning at an angle of 84 degrees 15 minutes. So it's not 90 degrees. You've also measured how far you are away from the bottom of the tree, okay, and you are standing 85 meters from the base of the tree. And then you can just barely see the top of the tree from your sight line. Okay, and you look up at the top of the tree, and your angle of sight is 68 degrees 50 minutes. We can't use SOHCAHTOA to solve this problem because it's not a right triangle. We can't use Pythagorean theorem to solve this problem. We want to know how tall the tree is, so we're going to call the tree X. And so we need to figure out if the law of sines would be appropriate. And so what I'm going to recommend that you do is assign some letters to the corners. So let's call that A, and let's call the top of the tree B, and let's call the person C. And let's set up and see if the law of sines would be appropriate here. So we've got A, bless you, B and C set up, paired up against A, B, and C. So we've assigned corner A to be the 84 degrees 15 minutes. And we've assigned corner C to be the 68 degrees 50 minutes. Where do I put the 85?
B. Side B. I think.
85.
Okay, 85 meters. And that's true, that is across from corner B. So does it look like I can use the law of sines here?
Yeah. No, you can't.
Okay, I heard a no and a yes. Now you're changing your mind. Okay, at first, why does it look like no, you cannot? There's no pair. But at second glance, what do we realize that we can use? We can use the rule for 180 degrees. So we're going to use the 180 degree rule, which says start with 180, subtract the 84.15, also subtract the 68.50, and in DMS, find the final value of that missing angle. Yeah, if you're in DMS, you should stay preserved in DMS.
26 degrees and 55
Inches? Minutes? All right, 26 degrees, 55 minutes. Now we have a legitimate case to use the law of sines because we have a pair of B's. So we're going to work with our law of sines. So that would be 85 over the sine of the angle we just found, which was 26 degrees, 55 minutes. And then which other one do we want to use, given the fact that we're trying to find X, which is the height of the tree? Do we want to use the A corner or the C corner? Okay, so I want the C side, which is X. Okay, and then sine of the 68.50. So we have our opportunity to cross multiply. You guys are probably faster at me with your calculators. So you're going to go ahead and x will cross multiply down to the sine 2655. And 85 will cross multiply down to the sine of 6850 even. So x by itself would be 85 sine 6850 all divided by the other. And remember, the words don't reduce each other. All right, so who's pretty quick on the calculator and can tell me what that works out to be?
Wow.
I know, because when I said it, I don't know why.
All right, 171 point, or 175.1.
Wait, am I trying
Is there any more to that?
Me too.
Do you want to round? It's 0.97. 1097.
What comes after the 7?
Zero.
Okay, so 0.97. And what are the units on that?
Meters.
Meters. Okay, 175 meters tall.
So that's C.
Okay, which is the height of the tree.
Right. Then we would never figure out side height, just height.
No, you're not asked. Nobody asks you. Okay, now, that's from the person's sight, eyesight level. Okay, so you got to think back. That really only measures from the person's eyesight straight across to here.
Right.
So the tree is probably taller or shorter than that?
Taller.
The tree is taller because you got to add, so you have to assume, well, about how tall are you or whoever they are looking at it. So if you're 5.5 feet or 6 feet or whatever, you would want to add something to make sure. So the tree is probably closer depending on the height of the person. Okay? No, but if you just use your own personal height, okay? Then the tree, if I used my height, I'd be 180.597.
You're 5 meters?
Oh, right, this is meters. Good thing. I'm not 5 meters. I'm not even 2 meters. Okay, so I'm probably 176.697 meters. Okay, so add a little bit in terms of my meters. So let's see what we can do with some bearing problems when the bearing doesn't work out nicely to be 90 degrees, like it has been in our SOHCAHTOA problems. We'll see if using the law of sines can help us sort of navigate these bearing questions. So let's think about 2 ships leaving a harbor, one at a heading of 127 degrees and the other at 231. So let's get those 2 ships going here. Let's put our harbor right here. And let's head out at a heading of 127 degrees. So 127 degrees, southeast-ish. So we're going to head out in a southeasterly direction. And remember, bearing is always starting from north, measuring out until we get to that line, that hypotenuse line. And so that is our 127 degrees. The other ship is heading out at a different heading. That would be 231. So that's more than 180. So our 231, that's going to be heading more in a southwesterly direction, so maybe more like this. Okay, and 231 degrees, if we label that, that's still measuring from north, but 231 is going to go all the way to that ship. So there I've got 231 degrees. Now we know the first ship was going for 4 hours at 37 knots. So we need to figure out how long that line is. So that would be a multiplication, 4 times 37. So we're going to end up with 148 as the length in miles of the first ship. Now the second ship we don't know. Okay, we do not know how fast it's going, so I can't tell you how long it is. But I do know that that final length is 317 miles apart from each other. So let's get some letters on here. Let's call ships A and B, and the harbor we're going to call corner C. And so if we can set up our data, our information, we'll see if the law of sines is going to be appropriate here. Let's see, what do we know? We know A is 148 because that's across from side A. We know that C is 317 because that's across from the harbor. And let's take a closer look at this harbor. What would the measurement of corner C be? The 127 only gets us out to the first boat, and 231 gets us out to the second boat. So what about angle C itself, which is hovering there in between? Right, yes, 104. So if we zoom way in here, we can recognize that this is 104 degrees, which is between the two ships. Okay, that number comes from the difference between 231 and 127, so that's a subtraction. And so our angle C is now going to be 104. That tells me that I am ready to use the law of sines because I do have a pair set up. So we're going to use the 148 over the sine of A, and that'll be set equal to 317 over the sine of 104, which is a great opportunity for us to practice our cross multiplying. So 317 times the sine of A will be 148 times the sine of the 104 degrees. So we need to get A by itself, which divides the 148 sine 104. And we're going to divide that by the 317, and then we'll also use an inverse sine to help us get that value. So making sure your calculator, again, is to set into degree modes. We want the inverse sine of 148, sine 104, divided by 317. So A, the angle, is 26.937 degrees. So let's fill that in. We know this to be 26.937 degrees. That helps me to be able to use the law of 180. If I combine that angle with 104, I've got 130.937. And I can subtract that from the total of 180. So that helps me figure out that B is 49.063 degrees. Having that means I can figure out my final pair. So my final pairing is going to be 148 over, let's see. No, I don't want to use the 148. Okay, that brings up a good point. Do I use the A pair or should I use the C pair? I'm going to recommend the C pair because that was the original information we had, the original data. There was no rounding, there was no decimals. So I think it's going to be better for us overall if we use the C pair instead of A. So I'm not going to use the 148 after all. I'm going to use the 317. So 317 over the sine of 104 degrees. And then I pair that with the B side that I don't know and the sine of 49.063. So I can cross multiply those, and I'll have B times the sine of 104, so I cross multiply down, and 317 cross multiplied to the sine of 49.063. So division will help me figure out that the 317 times the sine of 49.063 degrees would get divided by the sine of the 104 degrees. That'll be a more accurate answer if I'm using the C pair instead of using the other one. So, all right, so we are at 246.803, and that would be miles for our boat. So let's go back to our drawing, and we now know that this boat here has gone 246.8 61.803 miles. That tells us how far the boat went. It does not tell us the speed, which is actually what we are looking for. The speed of the second ship is unknown. So if it went 246.803 miles, we have to figure out how fast it was going. So remember, on the other side, okay, let's remind ourselves where that number came from. 4 hours, 37 knots, right? It was 4 hours times 37 knots, and that worked out to be 148 miles. The other ship over here, it has the same 4 hours because they left the harbor at the same time. We just need to figure out how many knots it would take to get to a total of the miles. So we just do the reverse. On the one side, on this side, we multiplied 4 times 37. That gives me 148. If I'm on this side, I need to work backwards. I need to take the 246.803 and divide it by 4 to figure out the speed that this ship was going. And when we do the division, we see that this ship was going much faster than the other ship. It was going 61.7 knots, which is super uber fast for a ship to be going that quickly. Okay? All right, so I hope that all of that put together makes sense to you, and you'll be able to have success on your Law of Signs homework this weekend. All right, have a good one. See you Monday.